Good evening. So this is my second session on graphing polar graphics or graphing polar equations. Now we are going to look at ways of graphing more complicated polar equations. Now this is a bit of a long video, so I will probably have to break it into two pieces. So let's see whether we can graph this one. R is equal to 5 sine 2 theta. Now if it was 5 sine theta, we could have graphed it. Why? Because then we could have multiplied both sides by r like I showed in the previous video, and then this would have been r sine theta, which would be y, and the left hand side will be x squared plus y squared, and we have a circle. But we have 2 theta here, so we can do the trick again. So in a situation like that, here is a method that you can use which might work most of the time but not all the time, but it's still worth knowing. What you do is you take the junk inside 2 theta and you set it equal to pi over 2, and then you solve for theta, and then you get what theta is equal to pi over 4. Then what this means is that we are going to draw what is known as a guide curve or a guide graph. So if you are drawing a guide curve, what we do is we plot some values of theta and we try to find the r values for that. Now this is not the actual curve, remember, this is only a guide curve. So now we need to find out what values should we put for theta. So the theta that we find here is a starting value, and not really the starting value is 0, but it's like the increment. So if theta is pi over 4, then you start at 0 and then you go by increments of pi over 4. So then what are the increments of pi over 4? Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. So we take this theta that we get by equating the junk inside to pi over 2, and we go by increments or whatever that you get here. So if you got pi over 6 here, then we would go by increments of pi over 6. If you got pi over 3 here, we could go by increments of pi over 3. So now we need to find out for each one of these thetas what would be the value for r. So the way we do that is we take each value and we plug in the original equation and we find r. So let's take the first one. The first one is pi over 4. So if you go to the original equation, we get r equals 5 sine 2 theta. We put theta equals pi over 4, and then we get 5 sine 2 times pi over 4. 2 and the 4 cancels out, you get pi over 2, and sine pi over 2 is just 1, so you get 1 times 5, which is what? 5. Okay, so that's the first value, theta equals pi over 4. The value of r is 5. So pi over 4, the value of r is 5. Then we go to pi over 2. Then you go to pi over 2, then you put r equals sine, instead of theta you put pi over 2. And then you get what? 2 pi over 2, and then you get 5 sine pi, which is 0. Now how did you know that this is 1 and 0? If you are nervous about them, you can draw the unit circle. But the nice thing about the unit circle here is that you only need the 4 corner points. See the 4 corner points? 1, 0, 0, 1, negative 1, 0, and 0, negative 1. You only need these 4. For example, if you want sine pi over 2, then what you do is pi over 2 is this angle, and the sine is the y coordinate. Now you can see that the y coordinate is 1. So because of that, this is 1. So 5 times 1, which is 5. And if you want a sine pi, this is pi, and the y coordinate there is 0. So that's how you get the 0. So 5 times 0 is 0. Next you go 3 pi over 4. When you plug in 3 pi over 4, you get 2 times 3 pi over 4, 2 times 3 pi over 4, and then you get the 2 and the 4 cancels off, you get 3 pi over 2. Sine 3 pi over 2. What is sine 3 pi over 2? 3 pi over 2 is here, and what is the sine? Sine is the y coordinate, negative 1. So you get 5 times negative 1, which is negative 5. Then you go put pi is doubled, you get 5 sine 2 pi. What is sine 2 pi? Is a full circle. For full circle is all the way up to here, right? And the sine is the y coordinate, which is 0, so you get 0. So 0 times 5 will be 0. And next you go what? After 5 pi over 4. So you plug in 5 pi over 4, you get r is equal to 5 sine twice 5 pi over 4. The 5 pi over 4 will cancel off, we'll get 5 pi over 2, Now what is 5 pi over 2? Let's start counting. 1, 2, 3, 4, 5. 5 pi over 2 is right here, and the y coordinate will be 1. So sine 5 pi over 2 is 1. So you put 1 here, and 5 times 1 will be 5. Next will be what? 3 pi over 2. So you put 3 pi over 2, you get okay, 2 times 3 pi over 2, 2 cancels off, you get sine 3 pi. What is sine 3 pi? Pi, 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 2 pi, 3 pi. We are back again here, and the y coordinate is 0. So sine 3 pi is 0. So you get 0 there, right? And finally, or one before the final, you have 7 pi over 4. When you put 7 pi over 4, what do you get? You get 2 times 7 pi over 4. Cancel out the 2, you get 7 pi over 2. Now sine 7 pi over 2, what is that? 1, 2, 3, 4, 5, 6, 7. You're back here, right? And the y coordinate is negative 1. So sine 7 pi over 2 is negative 1. So you get 5 times negative 1 is negative 5. Finally, we have the last entry that we need to fill, which is 8, 5. And see, and then what happens is, sorry, let's add 8 pi over 2, which is actually 2 pi, right? So this is 2 pi right here, the last one. So when you put 2 pi, what you get is then r becomes 5 sine 2 times 2 pi, which is 2 times 2 pi, which is 4 pi. 5 sine 4 pi. And what is so sine 4 pi? Sine 2 pi is 1 circle, sine 4 pi is 2 circles, and we are back at the origin, and the y coordinate is 0. So sine 4 pi is 0. So this whole thing is 0, and we get r equals 0. So we're back here. And now what we do is we plug those points in. Okay, what we got. Okay, so pi over 2 is 0, 3 pi over 2, 3 pi over 4. So we start from 0. So pi over 4 is 5, pi over 2 is 0, and 3 pi over 4 is negative 5. So pi over 4 is 5, pi over 2 is 0, 3 pi over 4 is negative 5, then pi is 0. 5 pi over 4 would be what? 5 pi over 4 is 5, so 5 pi over 4 is 5, and then 3 pi over 2 is 0, 3 pi over 2 is 0, 7 pi over 4 is negative 5, 7 pi over 4 is negative 5, and 2 pi is 0. Now remember, this is not the graph, this is the guide graph. But by using the guide graph, now you can actually draw the actual graph. Okay, so how do you draw the graph? Now take segment at a time. Let's take the first segment. As theta goes from 0 to pi over 4, what happens to r? R goes from 0 to 5. This axis is the r axis. Okay, this is the theta. So theta goes from 0 to pi over 4. R goes from 0 to pi. Is that clear? Alright, so how can I draw that? I can draw it like this. Why? Because as theta goes from 0, theta 0 is here, pi over 4 is here. As theta goes from 0 to pi over 4, the r is the length, remember, from the origin. So r starts at 0 and r goes from 0 to 5. Okay. Now when theta goes from pi over 2 to 3 pi over 4, or sorry, from pi over 4 to pi over 2, the next segment, okay, pi over 4 to pi over 2, what happens to r? R drops from 5 to 0. So as theta goes from pi over 4 to pi over 2, what happens to r? R is here now. R drops from 5 back to 0. Is that clear? So you get this petal. Now let's do what happens. See what happens after pi over 2. The next segment. The next segment is from pi over 2 to 3 pi over 4. Now when theta goes from pi over 2 to 3 pi over 4, what happens to r? R goes from 0 to negative 5. Now you got to be a little careful here. So pi over 2 is here, 3 pi over 4 is here. So when r goes from here to here, it actually goes in the negative direction. So it goes in the negative direction. I think I should. So it will be better if I can just illustrate it in this diagram. So we took this one. So we went like that, remember? Okay. Okay, so we went like that and we come back here. And when theta goes from 0 and from pi over 2 to 3 pi over 4, r goes from 0, r was here, to negative 5. So 3 pi over 4 was here, but negative 5 should be on the other side. So really it should actually take a turn like this. Okay. And when theta goes from 3 pi over 4 to pi, what happens? 3 pi over 4 to 5, r goes from negative 5 to 0. So then r will go back to 0. Now let's look at the next one. When theta goes from pi to 5 pi over 4, okay, which is pi to 5 pi over 4, theta goes from pi to 5 pi over 4, r goes from 0 to 5, right? So then, so r is 0 here. So once again, it takes a nice little turn and goes from 0 to, it's kind of getting on my nerves, but that's okay. All right, and then from 5 pi over 4 to 3 pi over 2, so 5 pi over 4 is here and 3 pi over 2 is right here. What happens? R drops from 5 at 5 pi over 4, r is at 5. It drops from 5 to 0, right? And so it drops it back to 0, right? And then from 3 pi over 4 to 7 pi over 4, it goes from 0 to negative 5. So 3 pi over 4 to 7 pi over 4 is right here, but it goes negative, so you go the other way. Right, and from 7 pi over 4 to 2 pi, right, you drop back to 0. So you really drop back to 0. It's very difficult to draw, it's becoming too intelligent. But you can see that actually you get a nice little 4-leaved petal like that. Alright, so before I sign off, right, I'm going to give you the video exercise, which is to draw r equals cosine 2 theta, which is just like that. So let me go through the steps again. The way I started was I take the junk inside, set it equal to pi over 2 and solve for theta. And I use those thetas as my guidelines for the graph, for the guide graph or the guide curve. So pi over 4, pi over 2, 3 pi over 2. And then for these guide thetas, I find the guide r's by just plugging them in. And once I have them, I plot them in the guide curve. So I have my guide curve now. Then I go segment by segment. First segment is theta goes from 0 to pi over 4, r goes from 0 to pi. So theta goes from 0 to pi over 4, r goes from 0 to pi. And when theta goes from pi over 4 to pi over 2, r comes back to 0, see? So r comes back to 0. And then from pi over 2 to 3 pi over 4, r goes to negative 5. So pi over 2 is here, 3 pi over 4 is here. So when it goes this way, it goes negative. So remember, actually it goes like that and then goes like that. And from negative 5 goes to 0, so negative 5 go to 0. And then from 0 it goes to positive 5, right? Okay, at when it goes to 5 pi over 4. 5 pi over 4 is here, so it goes to positive 5, right? Okay, and then it goes back from positive 5 to 0, again to 0, and then from 5 pi over 2 to 3 pi over 2, it goes to 0, and then 3 pi over 2 to 7 pi over 4, it goes to negative 5, 3 pi over 2 to 7 pi over 4, it goes to negative 5 like that and comes back to 0. Alright, so that's it. That's how you draw. You need a lot of practice to draw these graphs. We'll do one more in class or a couple of more in class when you come, but go through this video very carefully and you learn the art of how to draw these graphs, okay? And that's